Today we're taking a look at section 3.1 on statements and quantifiers. In chapter 3 we have moved into talking about logic, and in this case we're talking about logic as it applies to mathematics. So, statements and quantifiers. First of all, let's talk about what we mean by a statement. A statement is a declarative sentence that is either true or false, but not both simultaneously. Here are some examples. If you're holding up a pencil, you would say the pencil is yellow. The second one, today is not Monday. 2 plus 5 equals 25. 2 plus 5 equals 7. And negative 18 is less than negative 5. Notice that a statement may be true or false. It just can't be both at the same time. Okay, so thinking about the definition, it's a declarative sentence that is either true or false, but not both simultaneously. Let's look at some examples. I have the following are not statements. These are not statements. Indicate why they aren't statements. Pause the recording for just a moment and jot down why you think each one of these is not a statement. And then when you're ready to check your answers, go ahead and restart it and we'll go over your answers. Okay, hopefully you've recorded your opinions on why these are not statements. How are you is not a statement because it is a question. So it is not a declarative sentence. So a question will not be a statement. Okay, the second one, go to your room. Again, this is a command. It's not a declarative sentence. So that means it is not a statement. Number 3, or the third one, George W. Bush is a better president than Bill Clinton. This one is not a statement because it is an opinion. One person might say this is true and another person might say it's false. So anything that is an opinion is not a statement. Okay, and our last one, this sentence is false. Okay, if it's true, then it's saying it's false. If it's false, then it's saying it's true. So you're actually getting into a paradoxical situation, and so it's both true and false at the same time. So it's not a statement because it is a paradox. So we want a statement to be a declarative sentence that is either true or false, but not both simultaneously. Okay, deciding whether a statement is compound. Most often the way to identify a compound statement is to look for a logical connective. And what happens is the logical connective joins two component statements. These connectives include the words and, or, and then the if-then statement. Now be careful of names that include and, as they will not form compound statements. And I have some examples below, and let's look at these. The book is on the desk and the paper is in the backpack. Would that be a compound statement? And the answer is yes. Let me go to yellow because it's a little bit smaller. The answer would be yes because we have two component statements. The book is on the desk and the paper is in the backpack that are joined by the logical connective, the word and. The second one, you can go now or you can go tomorrow. Again, we have two simple statements or two component statements that are joined by a logical connective. So we do have a compound statement there. Next one, if you have the book, then we will go to the library. Again, we have the logical connective. In this case, it's an if-then. And the two component statements are you have the book, and we will go to the library. So those three are all compounds. So let me put C's here to indicate they're compound. Now the last one is not compound. In this case, and is part of the name of the manufacturer. So that gun is made by Smith & Wesson. That will be a simple statement. Okay, now let's move on to negating simple statements. Basically, to negate a simple statement, we either insert not or remove the word not as needed. For example, if you have this sentence or the statement, the pencil is yellow, the negation would be the pencil is not yellow. If we have the statement, it is not snowing, the negation would be it is snowing. Okay, so it is not snowing becomes it is snowing. Now the inequalities, they tell us we can't use the slash. You have a tendency to say A is less than B, so the negation would be A is not less than B. In the book, what they do, they're sneaky in the exercises. They tell us we can't put the slash in there. So we have to come up with another way to negate the statement. And basically what we're doing is we're finding all the other possibilities. The negation of a less than will be a greater than or equal to. Okay, so that's all the other possibilities. The negation of a greater than becomes less than or equal to. The negation of less than or equal to is greater than. And finally, the negation of greater than or equal to is less than. So we're looking at all the other possibilities. All right, it looks like my symbols didn't carry over here. I had trouble getting these to draw in. It's an upside down capital V, the connective and. Forms a conjunction is what we refer to it as. And So if we wanted to do it symbolically, we could use P to represent the statement he is tall, Q to represent the statement she is pretty. If we wanted to say he is tall and she is pretty, we could do it symbolically with P and Q. P and Q. The word or, when we join two separate component statements with or, form a disjunction. So if we wanted to say he is tall or she is pretty, P or Q. And then finally not, to say he is not tall, we would put not in front of the P. And it uses what we call the tilde, used in foreign language. Okay, next we have quantifiers. There are two types of quantifiers that we work with. Universal quantifiers, which include or